So Unit 5 is all about trigonometry, and I wanted you to review the basic trig rules on your own, and of course you can post questions or ask questions about them. It's not the idea is that you have to know it all on your own. It's just that basically we're going to need that stuff in order to move forward. So if there's anything about that you're not sure of, feel free to ask or post. You can see that we're starting today with acute angles, and then special triangles, and then angles greater than 90 degrees, and then angles up to 360. And really this here is the main bulk, I guess, or difficulty in this unit. So I'm gonna start today with a bit of a think ahead question. Okay, so let's just go down for a sec, and just to remember about trig ratios, that the sine function, okay, its input is an angle, its output is a ratio. And specifically, what ratio does it output? It creates a hypothetical right triangle with this angle in it, and then it tells you what the opposite side would be divided by that triangle's hypotenuse. Now, you may also remember that there are questions where you need to go backwards, where you need to find the angle, and what you are given is the ratio. So right away I wanted to introduce this idea that you have another function called inverse sine, and what this does is it takes an input as the ratio, and its output gives you back the angle. Okay, so that's why this is sine, this is inverse sine, and these functions, as we know, are inverses because they undo one another. If you put an angle into sine, it gives you a ratio. If you put that ratio into inverse sine, it gives you back an angle. Now, when you're talking, so go back to our unit list for a second here. When you are talking about acute angles, which is to say angles less than 90 degrees, between 0 and 90, that picture is all nice and good, right? The picture I just sketched, that sine and inverse sine are okay. But I want to introduce a problem, like I said before, a think ahead problem. I'm going to do the sine of 30 degrees. Okay, so I type sine, I type 30 degrees, and it tells me the ratio. The ratio is 0.5. So if I do inverse sine of 0.5, it gives me my 30 degrees back, right? No problem. This is what inverse functions do. Everything makes sense. Now, where this is going to start becoming more difficult is, what if I said sine 120? And I don't actually mean 120, I mean 150, sorry. What if I did sine of 150? It's also 0.5. So my think ahead question right now is, why is that a problem? Or rather, how is that a problem? And based on what you learned in previous units, what do you think we might do about this fact? Or, like, where have you seen something like this before? So I'm going to post it right now. So we're going to come up with this idea here of, I'm just going to write it down in this activity feed. So again, give an answer if you have one. Why is the fact that sine 30 and sine 150 are both equal to 0.5 potentially a problem for us? And where have we seen this before? Okay, I want you to think about that. It's not really going to come up today. It's not going to come up for a few days, but it will help you if you get your head in this, if you get in this headspace right away. Okay, let's just go back and talk a little bit about the other trig ratios. So sine, cos, and tan, we know is opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. The reciprocals of these ratios are called cosecant. Cosecant goes with sine, secant goes with cos, and cotangent goes with tan. If you're ever not, some people mix up secant and cosecant, remember that each pair has exactly one co in it. There's tan and cotan, there's secant and cosine, and then there's sine and cosecant, right? So there's always like one pair of cos in each of them. Sorry, not pair of cos. One individual function has a co. I often mix up the fact that secant goes with cos, so that's how I try to remember it. Okay, these ratios are the exact same as the one above. They're just flipped over. So, and you run into one of these problems here right off the bat, which is a terminology problem. I just said that sine with a -1 is inverse sine. Okay, so sine -1, oops, this is inverse sine. However, oh, I see what I did there. Sorry, so with a -1, that's inverse sine. It undoes what sine does. Okay, now this sine x, let's put it in big brackets so we could see, to the power of -1, okay, with the -1 there, is 1 over sine x, and we know that that is equal to cosecant x. So I don't want you to mix these up. They both have a -1, unfortunately. One means inverse, one means reciprocal. Okay, so these three, they're called the reciprocal identities because they're flipped over fractions, and you know how to flip over a fraction. You raise it to the power of -1. So just be a bit careful. A -1 here is inverse. A -1 here is reciprocal. Okay, so how do we compute the value of a reciprocal ratio? All we have to do is do the reciprocal of the primary ratio. So for example, here I know that I'm going to write down, sorry, cosecant 36 degrees, I'm just going to copy paste the degrees, probably make this faster, would be the same as 1 over sine 36 degrees. Okay, and based on that, this is pretty easy. You just find out whatever that is. So let's go back to here and go sine 36 degrees. It's 0.59. It's customary in trig to keep 4 decimals, so let's keep 4 decimals. So 5878. Okay, and then of course we need the reciprocal of that, so we're going to go 1 over c, or we're going to go c to the power of -1. Either way works, and we get 1.7013. Now, if you're using GeoGebra or certain calculators, there is just a cosecant function that you can put in the answer directly. I'll just show you that quickly. So the other thing, if you're using GeoGebra here, is you can just type cosecant 36 degrees, and it comes up with 1.7013 right away. So feel free to do that as well. Okay, secant of 74. Again, I'm going to write that secant of 74 is equal to 1 over the cosine of 74, and therefore is equal to 1 over, and then let's do cosine of 74, gives you 0.2756, and that must be close to the number 4, I guess. 3.628. Okay, and that would be the answer. So when you're seeing a reciprocal ratio, just remember, you do it the same way you do any other one. Just put it on the bottom, change it to its primary ratio, so change cosecant to sine, but then put it on the bottom of the fraction, and then just solve it. All right? So it says find the values of the 6 trig ratios of 47 degrees. So let's make a quick table. We'll make it 6 by 2. We'll say sine 47. Actually, let's do it like this. Okay, so we'll do sine, and underneath sine we'll do cosecant, because those two are related. Over here we'll do cos, and underneath here we'll do secant, because those two are related. And over here we'll do tan and cotan, because they are related. Okay? Again, there's nothing to this. Let's just find the first three ones and we'll get the answer. So I'm going to type 47 degrees is my beta. So sine beta is 0.7314. Cos beta is 0.682. And tan beta 1.0724. Okay? Now to get the other ones, all I'm going to do is I'm going to do 1 over whatever I had above. Right? So I'm going to go 1 over I is 1.3673. 1.3673. For secant, we're going to go 1 over 0.682, which is going to be equal to 1 over j, 1.4663. And for cotan, we're just going to take this number and put it 1 over it. And we get 1 over k, 0.9325. Okay, so that's it. Just find the 6 trig ratios. All you're doing, get the 3 basic ones, sine, cos, and tan, and then just flip them over by either pressing your reciprocal button. You may have a button on your calculator that looks like that, or you may have a button on your calculator that looks like that. Those are your reciprocal buttons. Okay. If you don't have either of those buttons, then you do x to the power of, so x, then to the power of, and then -1, and that would work as well. Okay, write the 6 trigonometric ratios for the 2 acute angles in the right triangle with side lengths of 12, 35, and 37. Okay, so the 2 acute angles would be, of course, the 2 angles that are not 90 degrees. And so what we're going to do here is we're going to do the same thing I did up above, but we're going to need to double it because there are two angles. Now, before we do this, let's get GeoGebra to draw the picture so we know the answer, and then we'll look for how to get that answer. So how do I make a triangle with lengths 12, 35, and 37? How would you do that? How would you draw such a triangle? This is actually really clever how to do this. It's interesting. So here's what you do. Start with a point at 0, 0. Then start with a point, 37 units away. So let's say we have a point at 37, 0. So we know, right, that the triangle we need to draw has one side length is 37. I'm going to rename this side length to be C because I actually want to make a point about how to name these things. Now, what's the other thing we know about this triangle? We know that one side is length 35. So watch what I do. I make a circle at point A with a radius of 35. Then I make a circle at point B with a radius of 12. Guess where my triangle goes? My triangle goes exactly where C is because it's 35 units away from A, right? Which is what I want. It's 35 units away from A. I'm going to rename this to lowercase b. And it's 12 units away. It's 12 units away from B, right? So, of course, I don't need these circles. It's just using them to draw the picture accurately in the first place. So now I've got this drawing, and I want to point out something about how you label your triangles here, okay? When you're labeling triangles, capital letters go at each of the corners or the vertices of the triangle. Lowercase letters represent sides. Let's just write this down quickly. Capital letters represent angles, and they go at the vertices of the diagram. Okay? Lowercase letters represent side lengths. Okay? If you're talking about an angle where it's confusing which angle you mean, for example, let's say I was looking at this shape and I wanted to talk about the angle B, but the one that was over here, not the one that was over there. If I say angle B, you won't know which one I mean. So if you need to specify an angle, use 3 letters that trace it out. For example, angle ABC, for example, would mean angle A. So you start at A, go to B, go to C. I know what angle that is. It's this angle down here in the corner. Now again, that really isn't necessary if all you're drawing is a triangle, because if you say angle B, I know which one you're talking about. But if you say angle ABC, I'll still know what you're talking about. Now again, to remember, my triangle is it's a perfect drawing, right? It's not one you're going to be able to draw on your paper, unless you're using a ruler and a protractor, but I'm not expecting you to do that. But what my triangle can do for us then, since I've drawn it perfectly, is get the angles. So what I'm going to do is I'm going to type angle CBA. Okay, so that goes there. Then I'm going to do angle BAC. And then I'm going to do angle ACB. Okay, and you can see that the answers that we're looking for are 90, 18.92, and 71.08. And actually doing this has made me realize that we don't actually need these angles in order to give the answer. So I know what they are because I used the program to get them, but we don't actually need them. So let's see why we don't need them. Okay, so what I'm going to do here is let's hide them for a sec, and let's keep my diagram and bring it into Word. And so based on this diagram, okay, so let's do what we were asked. So it says write the 6 trig ratios for the 2 acute angles. So I'm going to say, instead of sine 47, I'm going to say A, because A is an acute angle in my picture, right? And right, so now we know we could measure A using the program, but we don't need to, because all it says write the ratios for the 2 acute angles. I don't actually need to know the side to do that. All I need is the opposite over the hypotenuse, and I can do that here because if I look from the perspective of angle A, the opposite is 12 and the hypotenuse is 37. So the answer would be 12 over 37. Now let's go back for a second and check that answer. If I type 12 over 37, I get this number, okay, 0.3243. Now, the angle that was over here was beta. If I type sine of beta, I get 0.3243. I get that exact number, right? So you don't need your calculator if you already have the ratios that you need, or the values that you need. Here is the hypotenuse over the opposite, so it's 37 over 12. The cos was the adjacent over the opposite, which would be 35 over 37. The secant is the opposite over the adjacent, which is 37 over 35. And the tan, right, let's look at the tan, is the opposite over the adjacent. So the opposite over the adjacent, which is 12 over 35. Finally, the cotan would simply be the adjacent over the opposite, which is the 35 over 12. Okay, so these are the 6 ratios if I was looking from the perspective of angle A. Now, of course, I could also do the exact same question, but look from the perspective of angle B instead of angle A. So let's just quickly switch all these to B. And what would change? So now when I'm looking from the perspective of B, the opposite is now 35, and the hypotenuse is still 37, and the adjacent is now 12. So how would that change everything? Well, my sine would become 35 over 37, and my cos would become 12 over 37. Do you notice how one angle's sine is the other angle's cos? And this angle's sine is this angle's cos, right? They kind of swap with one another. Here, of course, we just flip it over, so we get 37 over 35. Here we get 37 over 12. For the tangent, the opposite is now 35, and the adjacent is now 12. So these two just literally flip over, 12 over 35. Both of them just swap. Okay? All right, so that's good. Now it says for question 3, oh sorry, question 3 is a different question. It says find the value of theta to the nearest degree. All right, so let's do that. How do you get the angle when they give you the ratio? Again, think back to where we started today. Where we started today was the concept of the inverse function. Sine takes an angle and gives you a ratio. Inverse sine takes a ratio and gives you back an angle. So let's go back down, to this, and we're going to go the cotangent x is equal to 1.234. Therefore, tangent x is equal to 1 over 1.234, right? And therefore, x is equal to inverse tan, okay, of 1 over 1.234. Okay, to do inverse tan, you probably have an inverse tan button. If you're using GeoGebra, then you type a tan. For what this means is arctan, which is the old way of of indicating what's the inverse of the function. And I think, let me just check this quickly, and I'll just get back to you. So 1 over. Okay, it gives me in degrees. I think GeoGebra is default to degrees, but if you need to put it in degrees, a tan d, I think, also does it in degrees. Let me just. Sorry. Yeah. So if your GeoGebra doesn't give you an answer in degrees, you can do a tan d. But again, just use your calculator. I'm sure you have an arctan button on your calculator. So 39.0204 degrees. And then it says round to the nearest degree, so we'll just round it to 39. Okay? And that's how you would solve an answer like that. Again, we should be able to check this by typing cotan of our angle 39.0204. And the answer is the 1.234 that we started with. Okay? Let's try another one. Secant x is equal to 2.561. Therefore, cos x is equal to 1 over 2.561, right? Because the inverse, it's not the inverse, sorry, the reciprocal. And therefore, we do inverse, so we write it like that. Then we said x is equal to, right, to get at x here, you've got to get rid of cos. How do you get rid of cos? You get rid of cos with inverse cos. Okay, and so that's what we're going to do. I'm going to type a cos for inverse cos, 1 over 2.561. Gives me 67.02 degrees, which we're just going to say is 67 degrees. Okay, round to the nearest degree. Okay, just a few more and then we're done for the day. You can try some of these and then try that question I left you with if you want. So here, cosecant x is equal to 4.032. Therefore, right, sine x is equal to 1 over 4.032. And therefore, x is equal to inverse sine of 1 over 4.032. We're just going to go back here. We go inverse sine, 1 over 4.032. I get the number 14.36 degrees. Okay? And therefore, and rounded to the nearest degree, x equals 14 degrees. Okay? So again, let's just try that quickly. Cosecant. Okay, so cosecant of 14.3601 gives me 4.032, which is what I was looking for. Okay. Okay, so secant theta is equal to 5 over 2. Okay. Therefore, so let's write this one. So sorry. Secant x is equal to 5 over 2. Therefore, cos x is equal to 2 over 5, right? We take the reciprocal. And therefore, x is equal to inverse cos 2 over 5. And that is, just go over here, a cos 0.4. 0.4 is 2 over 5. 66.42, which we're going to round to 66. Okay? Last question, it says cotan of 2 over 7. So cotan x equals 2 over 7. Therefore, tan x is equal to 7 over 2. Therefore, x is equal to inverse tan of 7 over 2. And therefore, x is equal to, let's do inverse tan 7 over 2. We get 74.05 degrees. And therefore, x is equal to 74 degrees. Okay? So just for today, just reminding how the inverse function works, what it does. The inverse function is when you do not know the angle. If you don't know the angle, but you do know the ratio, you use the inverse function in order to get the angle. Okay? The 6 trig ratios relate to the sides of the right triangle. Trig ratios are typically used to calculate the unknown length or unknown angle. So if you're missing an angle or missing a side, you can use a trig ratio to find it. And today we're just reviewing what are the reciprocal ratios, so cosecant, secant, and cotangent, and then how do you get an angle if you know the ratio. Okay, so just try some of the homework for tonight and maybe try to answer my question on the Think Ahead section that I posted.